Good morning, everyone. You're listening to the Sci-Files, an exposure segment featuring Michigan State University student research. We're your co-hosts, Chelsie Boudou
and Daniel Puentes.
Today we're here with Matt Kuhn and Jaimie Strickland. May you please introduce yourselves?
Sure. So my name is Matt Kuhn. I'm a veterinarian and a current Ph.D. student in the College of Veterinary Medicine. Specifically, I'm in the Comparative Medicine and Integrative Biology program. So what I do there is we try to study cattle because we're in the College of Veterinary Medicine. And so we're trying to understand what makes cows sick, especially around the time of calving. So my research is focusing on inflammation and how that contributes to their health and disease.
And Jaimie?
Hi, I'm Jaimie Strickland. I'm also a veterinarian and a PhD student in the veterinary school with Matt. Our lab is called the Meadowbrook Laboratory. And I have a nutrition background, and so what I mostly study is how nutrition affects the immune system of dairy cows around calving.
Is there a particular reason why your research lab looks at cows?
So the focus of our lab is really to improve the animal welfare of cattle. So most of our research surrounds trying to prevent disease rather than treat it. We really believe in trying to reduce the amount of antimicrobials we're using in our animals. So by preventing disease rather than treating it, we can reduce the amount of antibiotics we're using and then reduce the creation of antibiotic resistance.
What antibiotics are you looking at?
So we don't specifically look at antibiotics themselves. Our attempt is to reduce the amount of disease that's occurring in the first place. And by reducing disease, we're reducing the need to even use antibiotics at all.
Interesting. And what diseases are you particularly looking at?
Most of all, we're looking at inflammatory diseases. So the most common one that we like to look at is called mastitis. And it's essentially an infection of the mammary gland of cows, or what makes the milk. And so that's one of the most costly diseases to the dairy industry, but it also can cause a lot of pain for the animals. So we focus there to try to relieve some of the pain and improve animal welfare the most that we can.
Well, it sounds like this project has a lot of wide-ranging applications, not like you mentioned, not only for the welfare of the animal, but also the dairy industry as a whole.
Absolutely. The dairy industry is a multi-million-dollar industry, not only in the U.S., but especially in Michigan. We're one of the top 10 dairy-producing states in the country. So we really take seriously taking care of our animals, trying to improve their health, improve how much milk they can make so that we can feed our country and feed people at an affordable price. And so we want to do what we can to help our farmers to help their cattle.
Which agency does this research fall under? I'm really curious.
The majority of our funding comes from the United States Department of Agriculture mostly.
Where does the rest of it come from?
So the lab is also run by a few privately endowed funds, as well as some other donors. The Michigan dairy industry supports us a little bit, as well as the federal Department of Agriculture.
And do you work with the cows in person? Like, is there a pasture or facility that you work at?
Certainly. So one of the best parts about being a veterinarian for myself and Jaimie is that we go out to the farms quite a bit. We don't like to stay cooped up in the lab too much. So every chance we get, we're trying to get out to the farms. We have a farm here on campus that has about 250 cows that are milked daily. And then we also go out to a farm quite commonly up north a little bit that has more around 3,000 cows and is more representation of a common dairy farm in Michigan. So almost weekly, we're up at these farms collecting samples or doing treatments and things to try to use what's happening in real life, and then we can take that real life back into the lab.
It's really cool that you get to go out to a farm and get out of the laboratory and interact with animals, especially cows. You said that you collect samples over there. What samples do you collect, and what experiments do you perform on these samples?
The majority of samples that I'm collecting for my project are going to be blood and milk, because they kind of represent the two major compartments that the animals that I'm interested in. The milk specifically kind of shows what the mammary gland is doing, because interestingly, the mammary gland tends to have a immunological environment that's different than the rest of the body at times. And so it's good to compare what we're seeing in the blood, which kind of represents the body as a whole, versus what's happening in the milk, which represents the mammary gland. And since we're focusing on mastitis, which is that infection of the mammary gland, it's important to understand the differences between the two. So when we get back to the lab with our samples, we can measure different things in them to see what the animal's producing to combat infections. So specifically, what I measure is something called an oxylipid. These oxylipids are inflammatory mediators or communicators that kind of control inflammation. And so if you've heard of omega-3 fatty acids like fish oils, so these oxylipids are derived from these fatty acids and metabolized from them, and then they try to regulate inflammation in different ways.
I would assume that if you have too much of these oxylipids, that would also be bad as well, right?
It certainly can be. It depends which ones there are. So there's over 250 of these oxylipids that can be produced in different ways through different enzymes. And so some of them are quite bad, like they're very pro-inflammatory, whereas other of them are anti-inflammatory and they're good. And so it's kind of the balance of the good and the bad that goes back and forth that can drive inflammation and drive disease. So we're trying to understand many times how this balance is playing out.
I'm curious, can this kind of infection occur in women as well?
It can. It's less common because humans aren't, they're not challenged as much to produce as much milk. Our dairy cattle, we've genetically bred them to be very good at producing milk. So they have a very big energy demand. And because they have this energy demand, their metabolism is kind of kicked up. It's like they're running a marathon constantly. And so because of that, they tend to get sick a little bit more often. And so they see it more often than we would see it in humans.
And how were the cows genetically modified? Was it done in vitro or was it done through selection?
Yeah, so it's through selection. We don't have any in vitro modified cattle really that are on the market right now. It's just been a slow progression over time, beginning hundreds of years ago, obviously, that it's slowly selected for cows that are better at producing milk, being better moms year after year after year.
Thanks a lot for sharing that, Matt. Now, Jaimie, from what I'm gathering, you're looking at the nutrition of these cows, and I believe that the nutrition of them would be very important with the production of their milk content. But could you please tell us a little bit more about your research?
Yeah, that's correct. And nutrition is certainly important for milk production. And actually, that's where most of the research is coming from when you're looking at nutrition in dairy cows. And there's actually very little data looking at especially vitamin nutrition and increasing the health of dairy cows. And so we're not actually sure how much to supplement with our vitamins to actually keep cows healthy.
So your project is focusing on a much more larger scale project compared to Matt's then?
Yes, that's correct. I'm using a bit larger data sets and actually looking more at descriptive data of cows that are actually on working farms as opposed to the more mechanistic things that Matt's doing.
Well, I think it's really great that we're getting two different perspectives on this episode. We have one from the microscopic side of things when it comes to cows, and we have one on a much more macroscopic scale. I think that's really interesting.
Yeah, it's super cool, Danny. I'm also curious, what vitamins do you look at?
So I'm looking at vitamin A, beta carotene, and vitamin E. And I'm looking at all those three vitamins in general, but I'm focusing most of my research on vitamin A.
And why did you pick vitamin A?
I chose vitamin A because we found in these larger data sets that I've been looking at that vitamin A is associated the most often with diseases that we see in cows after they calve. And so I'm focusing on vitamin A so that we might be able to improve the way we supplement cows to prevent these diseases from occurring.
It's interesting that you're looking at vitamin A because vitamin A is very linked to neural tube defects. So when, like retinoic acid, for example, there are actually studies where they will feed animals retinoic acid and some of their offspring will actually have like a neural tube defect such as spina bifida. And I'm curious, do you also look at some of the ways like how the vitamins would be affecting the offspring of these cattle?
So in my research, I'm not looking exactly at how vitamin A might affect the progeny of cows. So cows are a little bit different in humans in that not a lot of vitamin A actually passes through the placenta. And so cows are generally born deficient in vitamin A, and they get all of their vitamin A primarily from colostrum, which is the first milk produced by the cow after she has her calf.
So with that being said, what is a natural source of vitamin A that cows can feed on?
So vitamin A can come from beta carotene, which is another fat-soluble vitamin that can be found in plants. So cows that are grazing on grass can consume a lot of beta carotene that can be converted to vitamin A after it's been absorbed in the intestine. However, most of our cows are fed in barns, and the feed is brought to them in what we call a total mixed ration. And so vitamin A is supplemented from a synthetically produced vitamin.
And where does vitamin E get into the mix of all of this?
So vitamin E is also supplemented in the diets of dairy cows because they can't get enough from the forages that we feed them in order to keep them healthy. And it's been more commonly studied in the past than vitamin A, so we know a lot of what it does and how it can help the immune system of dairy cows. And so I'm including it with my big data sets, but for my smaller, more mechanistic studies, I'm focusing more on vitamin A because we know less about it.
Now, this is a question for both of you, actually. Has the work that either of you performed actually affected the results or conclusions that you've made in a different project in your lab?
To an extent, yes. So through the mechanistic studies that I'm doing, I've kind of identified a single enzyme that I really like to focus on to study these oxylipids that I work with and how they affect inflammation. And in doing so, I actually found out that the enzyme I study is also affected by vitamin E, something that Jaimie studies. So with that, I've kind of come to rely on Jaimie for a lot of things because she's been kind of the expert in the lab of vitamins in general. And so since I'm starting to incorporate some details of vitamin E into my work, I've now begun to rely on her and have one project start to build on another project.
And Matt's research has helped frame a bit of my research since he's looked at these enzymes in different tissues of the dairy cow. He's found enzymes that metabolize vitamin A in the udder, which has helped me to narrow down what I'm looking at in the lab.
That's really interesting. How do you measure inflammation and immunity? Because there's a bunch of different ways how you can measure inflammation. You can stain the cells do you even look at cells or do you just do analyses on the blood and the milk samples?
Yeah, great question. In our lab, we don't do a lot of tissue work. At times we do. For example, one of my recent papers I'm just putting together now is looking at the relative gene expression of different enzymes in tissues. So trying to see which enzymes are increased or decreased in different tissues around the body. But for the most part, we really focus on blood and milk. And the major way that we categorize inflammation is through measuring these oxylipids by liquid chromatography mass spectrometry, which is a fancy way to say we can measure extremely small metabolites very accurately. And then by categorizing which metabolites are present, which oxylipids we have, we can understand kind of if inflammation is being driven or if it's being kind of shut down. We can also measure something called oxidative stress, which is a way that cells become damaged at times of disease. So we've developed a way to actually measure the lipids that make up a cellular membrane, and we can tell when those lipids have become damaged. And one of the hallmarks of oxidative stress is this damage of these lipids. And so that's one of the ways we can focus on how bad inflammation is or how severe the disease has become.
What do you gather after you've learned what type of lipids are damaged? Can that help you with your analysis even further?
That's one of the big takeaways we take back to the lab with us. Once we can understand how oxylipids are changed in an actual cow, we can then go back into the lab and try to model it in our cell cultures. So one of the things we can do is we take endothelial cells, of the cells that line the blood vessels of cows, and we grow them in our lab. Once we've grown them, we can then treat them with different antagonists or different substrates like the omega-3 fatty acids and try to understand how the oxylipids are actually being made. So kind of taking what we're seeing on the farm and then trying to replicate it in the lab so that we can then manipulate it to then take it back to the farm.
And can you define for our audience, I'm not sure if this is actually mentioned, what is an oxylipid?
It's an inflammatory communicating metabolite or communicating molecule. Essentially, it's a fatty acid that has been modified chemically by either an enzyme or non-enzymatically that now has a inflammatory reaction to it, whether that's decreasing inflammation or increasing inflammation in some way.
Thank you for that explanation, Matt. Now, both of you have mentioned that you are both in the veterinarian/Ph.D. program. What is being in a program like that like?
So for me, I'm doing both the combined DVM and PhD program, a doctorate in veterinary medicine and a PhD, somewhat at the same time. In Jaimie's case, Jaimie went to vet school first and then got some real world experience and now has come back to get her graduate degree and utilize that real world experience. For my case, I started vet school several years ago. And then while I was in vet school, I began working on a PhD concurrently. About halfway through vet school, I took a year off to start some of the preliminary research for my PhD. I then went back into vet school, did some clinical rotations, and graduated. And now I'm in my third year of my PhD trying to finish this degree out.
Okay, so then you already have your veterinary degree.
Correct.
Wow, that's incredible. Congratulations.
Thank you.
And congrats to you too, Jaimie. Why would you need both of these degrees? Like, what do you gain with both of them?
So for me, I went into private practice initially thinking that I would stay in private practice and not go back to school for any continuing education. However, once I was in private practice for a while, I realized I had a lot of questions, especially about nutrition, that I wanted answers to, but was unable to conduct any kind of real research studies on the farms I was working with. And I got frustrated by not being able to better improve the health of the cows that were owned by my clients. And so that was what made me decide to go back to school for a PhD. And for me, it's been really great to be a veterinarian getting a PhD because I kind of get the best of both worlds. I still get to go occasionally practice medicine on our university dairy farms, but I also get to play with cells in the lab, and it's a lot less stressful working with cells than with live animals.
Thanks. So then it sounds like the biggest difference between a PhD in animal science versus a degree in veterinary medicine then are the clinical rotations that a person would go through.
Yeah, I agree. The initial education is a little different as well. I like to think of it as, for veterinary school, you're given a book and asked to memorize everything in the book. For a PhD, you're more of given a pamphlet and told to memorize everything in the book about the pamphlet without having the book in front of you. So there's a lot more research to do on your own in a PhD than there is in a vet school where they somewhat give you all of the information. You just have to memorize it. Well, I think in vet school, there's a lot more information to take in than during a PhD.
And the benefit of having both a PhD as well as a DVM is that we're able to do research that affects the health of animals, and we're the best equipped to do that because we both have the knowledge of how animals become sick and how we can treat them to make them healthy. And then we also gain all of the experience in how to conduct a proper research trial and publish papers and things like that.
Cool. Now it's making more sense to me. You both have a DVM, which is a doctorate in veterinary medicine, and that helps you a lot more with your studies because you have the background of the knowledge of the animals, like why they're sick and whatnot. So what do you both want to do afterwards? Since Jaimie, you already went into the private industry area, what are you thinking about going back? And the same question to you, Matt.
Sure, I'll start. So for me, I really have a passion for teaching and research. So I'm hoping to stay in academia and work in a vet school where I can teach veterinary students about animal nutrition, as well as further conduct research studies to improve the health of dairy cows.
Yeah, so my future is taking a little bit different track. I'm hoping to go into science policy. So my plan in the next year or so is to move to DC and start a career down there with the federal government. So I'm trying to use my PhD, especially the communication skills that come with having a PhD, to better inform science policy, but then also use my DVM to understand, especially agriculture and what we can do for the agriculture industry to better make policies and regulations to help not only farmers and animals, but to feed our country as well.
It's really interesting that you bring up science policy, Matt. So Danny and I have a strong passion towards science communication, obviously, since we're on the radio talking about science, but we also know that MSU is actually going to be having a series of science policy lunches hosted by MSU SciComm. So that's a science communication organization, and starting September 5th, every other week on a Thursday, you can go for lunch and start learning about what is policy and then how to advocate for science and things like that. So I think it's really interesting that the school and different organizations are starting to agree with you and believe that we should further science, and that even if you're not going into academia, you can still advocate for what you believe in.
And it's a two-way street. You need the scientists to inform the politicians, but you also need the politicians to inform the scientists about what policies are currently in place. And learning about that intersection between the two fields can provide a lot of good for our nation as a whole, as well as the world. So I understood that Jaimie is just starting in the laboratory and Matt is a little more seasoned. Can you describe about what that relationship has been like for Jaimie, you being the mentee, and Matt, you being the mentor?
Yeah, so I started working in the laboratory this last January, and needless to say, I have very few benchtop skills. And so doing things like keeping cells alive and running assays was a foreign animal to me. And where I have the skills in working with cattle, I definitely lack the skills working with cells, everything from pipetting to making media, which acts as their food correctly. And so it's been essential for me to have Matt as a mentor to be able to show me how to do everything and to keep up my positive attitude and my abilities to be able to perform the assays I need to perform in the lab in order to get data and continue with my research.
At the same time, though, I've seen Jaimie as a mentor for myself. Even though I've been in the lab for 5 or 6 years now, having somebody join that has real-world experience being a veterinarian, since I've kind of come just from vet school straight into a PhD, being able to work with somebody that knows really what it's like day to day out on farms and can apply that knowledge to what we do in the lab, as well as somebody that's as passionate about writing as Jaimie is, to have alongside to bounce ideas off of. I've kind of looked up to Jaimie for a lot of different aspects of my work and trying to feed off of her knowledge and what she knows, and then better apply that to what I do.
And what both got you interested in animal science in the first place?
I wanted to be a veterinarian since I was 5 years old. And so I just continued with that track pretty much my entire life. And when I did animal science in undergrad here at Michigan State University, I discovered that I loved cows when I did a research project looking at dairy cow reproduction. And that's how I decided I wanted to work with dairy cows as a veterinarian.
My path follows a fairly similar way. I didn't start quite as early. I probably thought I wanted to be a veterinarian first in high school. And then I came to Michigan State and took an animal science 101 class. And during that class, I essentially fell in love with dairy cows. From then on, every lab I've worked in undergrad or graduate school has focused on dairy cows. And it's kind of just my passion has grown and grown ever since then.
It's interesting that you were really fascinated by dairy cows. I know a lot of people like to do research on the sheep farm or even with pigs. So why did you particularly like dairy cows?
For me, just something about dairy cows in general. They're very friendly and kind and curious creatures, and they're just really a joy to work with for me.
It's the exact same reasons for me. They're just so goofy and kooky and loving for being such a large animal that it's just great to work with them.
And then despite all of this time that you've dedicated towards research, are there any things or activities that you're involved with on campus at any point?
I don't do too much on campus anymore. During vet school, I was a part of several veterinary clubs like the Food Animal Club or our veterinary fraternity. Now that I'm in graduate school, I work with our Michigan Veterinary Medical Association on their legislative advisory committee. I also do Skype a Scientist several times a year. I know you guys have had a few people on that do Skype a Scientist, so I always like to take especially younger classrooms out to the Michigan State Dairy Farm, and I tend to give them a dairy tour and then answer their questions they have about cows and where their milk comes from.
Do you do that via Skype?
I do. I have Skype on my iPhone, and so while I'm out on the phone or out on the farm, I have my phone up, and I just kind of put in headphones and talk to them and try to show them the cows the best that I can.
I have developed an interest in science communication since beginning my Ph.D., and I was very grateful to partake in a SciComm-Con conference here on campus where I was able to develop more of both my oral public speaking skills, how to better talk to the general public about my science in a way that they can understand what I'm saying and get excited about what I'm doing, and how to also just really even increase my ability to communicate with other scientists.
Yeah, I think ComSciCon is a really great movement. It's nationwide, actually. It's not only in Michigan, and it's really great that you were able to participate. Thanks a lot for participating in this interview. We're very grateful to have had you both.
Yes, thank you so much. And I just have one last question. I can't believe I haven't thought of this earlier. What are your thoughts on cow tipping?
I don't think you can tip a cow.
You don't think it's possible?
I've seen a physics analysis of it, and it doesn't seem like it's possible.
This is not a call to have people go out and try this, by the way. It is illegal. Do not mess with the cows. You will get hurt. But thank you both again for taking the time to join us on this interview.
Yeah, thank you both so much. I really appreciate the opportunity to come on.
Thank you so much. It's been great.
Thank you to all of our listeners that joined us this week. And remember, the truth is in the science. Any comments and questions can be directed to Sci-Files at impact89fm.org. We'll see you all next week on Sci-Files.